it did not stop there. The references to Vietnam War are also linked in a way to IT and also to cryptography, security in ways that many of us may not be even aware of. I'm sure those students who have learned some amount of cryptography, right? There would be some students here, I believe, would perhaps have studied algorithms like DES, right? RSA, NoFish, AES, some of you, right? So I'm sure you are familiar with terms like key, public key, private key, right? Algorithms and so on and so forth. Now, interestingly, this is something which is impacted even by Vietnam War, but I'll tell you how and why. The first time cryptography became popular on computers was in the 1950s, because that was a time when people started saying that instead of doing cryptography using pen and paper, right, so you have just, let's say, algorithms which you manually write and manually run. If instead you run them on computers, they would not only be faster, but they would also be able to, let's say, do that job repeatedly without getting bored. So if, let's say, you run the DS algorithm 100 times, you pass some plain text, you pass some key, and you ask DS to encrypt that text into ciphertext. DS will not get bored. DS also will not make a mistake, which is what we will do. Right? If, let's say, we are asked to repeatedly compute ciphertext from some plain text, eventually we will get bored, or eventually we'll start making mistakes. And which is where people said that we should have cryptographic algorithms that could be run on computers instead of humans doing cryptography. And the idea gained momentum in the 1950s after the Second World War. So the US government around that time was starting to think that there should be a cryptographic algorithm which anybody, at least in the US, should be able to use comfortably, and it should be universal. Which means that if, let's say, I am an ordinary citizen, I am a government employee, I am, let's say, even in the top secret, everyone should be able to universally use one single algorithm. And obviously the key would differ, but algorithm would remain the same. And using that algorithm, I should be able to convert my plain text into ciphertext. And with this idea in mind, the US government floated this concept to an agency which is called as the National Security Agency in the US. Again, some of us may have read about National Security Agency. For example, when Hillary Clinton was here in India a few years ago, there was a representative of National Security Agency also with her, and then there were discussions about the national level security between India and US and so on. So this agency called as National Security Agency is responsible for all the national level secrets that the US has. Now, this particular agency is so feared, and it is apparently so secret that there is a joke that goes in the US which says that the long form of National Security Agency, right, that's the long form. So the long form of NSA is not National Security Agency. Okay, it is so secretive that people say its long form is no such agency. That is, the agency itself doesn't exist. But obviously it does exist, it's so secretive, and hence people call it as no such agency. So the US government had given this job to NSA to come out with an algorithm. Now NSA employed people who were cryptographers, who were mathematicians, who had background in computers, but they said, should we really invest our time and money in creating a cryptographic algorithm? Because everyone knew that creating a cryptographic algorithm is extremely tedious. It's a very, very difficult process. And around the same time, what had happened was the famous company IBM was also working on its own cryptographic algorithm. The background to which being that there is a person by the name Hurst Fistel, and Hurst Fistel is considered to be one of the famous cryptographers of that era. This person, Hurst Fistel, had come from Germany and he had migrated to the US in the Second World War days, because Fistel was a Jew, and in those days being a Jew and being in Germany, right, during the Second World War, pre-Second World War days, right, all of us know, was almost like a crime, and therefore he had migrated to the US. So this person, Hurst Fistel, had background in computers. He also used to break secrets since his childhood, so he had passion for cryptography. And when he came to the US, he had started working on a cryptographic algorithm. Eventually he succeeded. He came out with an algorithm which could encrypt some plain text using a computer, using a key that would produce some cipher text. Now he did not know what to do with this algorithm because he was a good technician, but he was not a good marketing person, and which is where he got employed in IBM. So IBM had employed him mainly for research in computer science and investigating how to improve some of their existing work and so on. So while doing this, Fiscal proposed his idea, saying that I have designed this algorithm, why doesn't IBM take it over and make progress? And IBM accepted happily. So IBM took over this algorithm. It eventually came to be called as DSP-1. That was the name that was given to this algorithm. And when IBM took this algorithm, it also started marketing it, because IBM saw no value in just taking an algorithm and keeping it without any practical purpose. So this particular algorithm, some of us may get surprised to hear this, but this was used in the 1960s by the Lloyds Bank in UK for cryptography. So two branches of Lloyds Bank, when let's say one branch wanted to send money to the other bank, or let's say send electronic messages, those messages were encrypted using this DSP-1 algorithm. We think cryptography is very new and we think it's employed just today, or let's say in the last few years, but it's not true. It has been there in the 1960s. So it was used in some form, this DSP-1 algorithm, and while IBM was working on it, as I said, a parallel thread was happening with the US government and National Security Agency, who also wanted to have a cryptographic algorithm. Then they came to know that IBM had this DSP-1 algorithm given to them initially by Hurst Fistel, and they said, now let's not spend our time creating a new algorithm, let's talk to IBM. So that's how NSA and IBM came together. And then NSA subsequently decided after a few discussions that instead of we creating a new algorithm, let's take over IBM's algorithm once it's ready. Now why I'm saying once it's ready? Because although it was ready, it had to be still packaged in a form which would make it more secure. The US government and NSA also had a lot of other restrictions, a lot of other conditions, which said that if the algorithm had to be really useful and had to be really secret, then these 5 conditions or these 10 conditions have to be added to make the algorithm more and more strong, let's say extremely sturdy. So these features were being added to this DSP-1 algorithm for a number of years. When finally the work was finished, the algorithm was ready to be released. And when the algorithm got released, there were 2 completely contradictory views about it in the general public. The first view, which was obviously the government view, was that now there is a cryptographic algorithm which can be used by anyone and everyone extremely securely. People should be happy, people should be very, very carefree because there is an algorithm that you can use securely now. And the contra view, or let's say the anti-view, was that this was an algorithm which was created by National Security Agency, which itself was so secretive that there was no point trusting it. And secondly, it was a US government sponsored project, which meant, and there is an allegation that I'll talk about, but there was an allegation saying that this algorithm deliberately had a flaw, okay, which I'll come back to. Eventually this algorithm got released. It was very, very widely used. It is used even today, and it is there in the syllabus of many of you, because it eventually got called as the Data Encryption Standard, or DES. So that is how the